Right, so in this segment, we're going to look at one more titration problem, and that is the titration of polyprotic acids, because there's two hydrogens that can come off. So let's look at the learning objectives here. We want to draw a titration curve for polyprotic acid titration and label the key points and be able to calculate the pH of key points along a polyprotic acid titration. All right, so the good thing is most of the work is already done. If the pKa's are fairly separated, and they almost always are by 5 to 7 pK units, even if it's only like 3 pK units, you can pretty much treat it as two titration curves joined into one. So you really only need to worry about one titration at a time, right? Up through this point, here, you just treat it as a weak acid problem with the pH, with the pKa being pKa1. And past here, then you can just treat it as a weak acid with the second pKa. With the pK is the pKa2. So you know how to do everything here and everything here. The one issue is right here at that first equivalence point. So why is that a problem? Because you have a concentration of HA minus there. It's mostly HA minus because you have reacted all of the HA minus. But remember, HA minus has two equilibrium. It's an equilibrium both with A2 minus and H2A. So it has those two equilibrium going on. So in most cases, to get the number exactly right, you'd have to solve two equations simultaneously. But there is one point where the math ends up simplifying. And it turns out that at the equivalent, exactly at the equivalence point, the pH is just the pKa1 plus pKa2 divided by 2. So near the equivalence point, once you start having an appreciable amount of A2 minus and H2A, then you do have to figure out the concentrations of all of them simultaneously. However, you do know that at near that point, the pH is going to be close to the pKa1 plus pKa2 divided by 2. Also, this is an area where it's changing pH pretty quickly, and so most of the time you're not titrating in that region. So again, the math to be able to get the exact curve in this area is complicated, but you know everything up to the curve, everything before that, and you know exactly at the equivalence point, the pK is the average of the two. That just requires a lot of algebra to go prove it. You can go look up the proof somewhere. I won't go over it because it's set up as the algebra.